Hello classmates, we will continue to learn knowledge of three-phase alternating current. In this lesson, we will learn connection mode of three-phase power supply. Connection of three-phase power supply, there are two ways. A star is also called a Y-joint, and triangle, also known as delta connection. Let's study the difference between two kinds of connections separately. Let's start. Y connection of three-phase power supply. If you put a three-phase generator, the tail ends of the three windings connects X, Y, Z together, become a common terminal. On the first end of three windings, U, V, W. This connection is called star connection, as shown in figure 4.2.1. The common point N is called the midpoint. The line drawn from the midpoint is called the neutral line or the zero line, represented in black or white. The neutral wire is generally grounded, also known as ground wire. From the first end of the coil UVW, the three leads are called phase lines, commonly known as fire wires, represented by yellow, green, and red respectively. This power supply system is called three-phase four-wire power supply. In the star connection three-phase power supply, there are two kinds of voltages, namely phase voltage and line voltage. What is the difference between the two? Voltage between each terminal line and the neutral line is called phase voltage. The phase voltage is expressed by UP, while the size of effective value is generally expressed by UU, UV, UW. Specify the reference direction of phase voltage as the positive direction of phase voltage. It's from the head end to the midpoint N. For example, the phase voltage UU is from the head end U1 to the midpoint N. Let UU equals square root of 2 times UP sine omega t. UV equals square root of 2 times UP sine of omega t minus 120 degrees. UW equals square root of 2 times UP sine of omega t plus 120 degrees. Let's learn what is line voltage. Voltage between any two terminal lines or phase lines is called line voltage. Expressed in UL using U phase to V phase voltage phasor of V to W phase voltage. Phasor representation of phase W to V voltage. The effective value size is generally expressed as follows. UUV signifies the effective value of U to V phase voltage. UVW signifies effective value of phase V to phase W voltage. UWU signifies effective value of phase W to phase U voltage. Specify the direction of line voltage, such as the direction of UV line voltage is composed of the head end U1, pointing to the head end V1, three-phase four-wire power supply, voltage rotating phasor diagram, as shown in the following figure, between line voltage and phase voltage. What is the relationship of satisfaction? Made of the above three-phase four-wire system. The rotating phasor diagram power supply voltage shows that line voltage phasor is equal to relation formula for phase voltage phasor as follows. That is, when the three-phase power supply is star connected, the magnitude of line voltage is 3 times the square root of the phase voltage. Line voltage phase leading the corresponding phase voltage phase by 30 degrees. So the relationship between the two can be expressed as the magnitude of the line voltage is equal to the square root of 3 times the magnitude of its corresponding phase voltage. The phasor of the line voltage is equal to the corresponding phase voltage phasor, multiplied by the square root of 3 and leading by 30 degrees. From the above analysis, we can see that when the three-phase power sources, such as generators or transformers, are connected in star configuration, two types of voltages can be provided. Phase voltage and line voltage in China General Low Voltage Distribution System. The phase voltage is 220 voltage, line voltage 380 V. Now let's learn delta connection of three-phase power supply. If the tail end of one winding of a three-phase generator is sequentially connected to the head end of another winding, with A connected to Y, B to Z, and C to X, three conductors are drawn out from the junction point, forming a delta triangle connection, as shown in Figure 4.2.2. Obviously, the voltage between each pair of terminals, namely the voltage of each phase, that is, the phasor of U phase and V phase line voltage, is equal to the phasor of the phase voltage in the U phase, V phase. W interphase line voltage phasor is equal to the phasor of the phase voltage in the V phase. W phase, U phase line voltage phasor is equal to the phasor of the phase voltage in the W phase. The phasor diagram between them is shown in Figure 4.2.3. That is, in the delta connection of a three-phase power source, the phasor of the line voltage completely coincides with the corresponding phasor of the phase voltage. Generally, the wild voltage is equal to the phase voltage. That is, phasor means that both are equal. For the symmetric electromotive force, the sum of the three symmetric electromotive forces is zero. When unloaded, there is no current in the closed loop. It must be noted that if the connection method of any one-phase stator winding is opposite, the sum of the three-phase voltages will not be zero. In the closed loop of triangle connection, a significant circulating current will be generated, leading to serious consequences, so the phase line can't be connected wrong. Usually start by connecting it as an open delta configuration. Once the voltage is measured at zero, then connect it as a closed delta configuration. So in practical application, three-phase power supply are generally not connected in a delta configuration. In this lesson, we learned two connection modes of three-phase power supply, namely star connection and triangle connection. Under the two connection modes, relationship between line voltage and its corresponding phase voltage must be kept in mind. In order to deepen your understanding and mastery of the key concepts covered in this class, there are two reflective questions for everyone to answer. Classmates, I'll see you next class.